This is section 5.2. I can graph exponential functions. So we're going to write the word exponential here. Exponential functions. And the warm-up, it says in the exponential expression 2 raised to the third power, what is the base and what is the exponent? So remember, the base is the big number that's sitting right here. So 2 is the base. And that makes this exponent right here, that's going to be 3. 3 is the exponent. And remember, the exponent tells us how many times we use the base as a factor. So some people mistake this and they think that this is 2 times 3. It's not. It's 2 used 3 times in a multiplication problem. So it would be 2 times 2 times 2, which would end up being 8. And then part B says, what does a negative in the exponent mean? Well, remember, a negative in the exponent means reciprocal. Reciprocal. Okay, so keep that in mind because that's going to come up a little bit later. Now, there are 2 things that we often forget about equations and graphing. The first one is if a point works in the equation, then it's on the graph. And vice versa, if a point's on the graph, then it works in the equation. Now, when we say it works in the equation, what we mean is it makes the equation true. Now, we can graph just about any equation, no matter how complicated it is, using an XY table. So we're going to write XY right here. Now, we've studied linear functions a whole bunch. They're very useful in modeling very simple situations. They're very simple shapes, they're easy to graph, but they don't work for everything. So when we run into things that are more complicated, kind of like the grains of rice and counting those, we may need something more complicated, like an exponential. Exponential. Okay, and the most basic form of an exponential looks like this. So f of x equals b raised to the x. So we've got this base right here, that's why we use the b, and then we're raising to that power right there. Now that's the most basic form, and we're going to learn how to make adjustments to that so we can model more complicated situations. But in the meantime, we're just going to go ahead and use an XY table to graph these so we can get a sense of what they look like. So on example 1, it says complete each table and graph the function. Use decimals or fractions if you need to. And then it says notice the axis scaling. So you'll notice that on the horizontal axis here, we count by 1s for each one of these tick marks. And then in the vertical axis, we count by 5s. So we need to be aware of that. And let's go ahead and graph this. So we're going to plug in a -2 and we're going to figure out what the y value is. So this is going to be 4 raised to the x, so that's going to be -2. Remember, the negative in the exponent means reciprocal, so this is going to be 1 over 4 squared. So this is going to be 1/16. So we've got -2 comma 1/16. That's going to be the first point that we're going to graph. And then we'll do another one. This is 4 to the -1. Again, the negative in the exponent means reciprocal, so this is 1 over 4 to the first. So this would just be 1/4. And then remember, if we raise any number to the 0 power, we end up with a 1. So this is going to be a 1 right here. And then we're going to do 4 to the first. That's a 4. And we're going to do 4 to the second. Remember, that's not 4 times 2. It's 4 times 4. It's 4 used twice. So that's going to be a 16. So we've got 16 right here. So let's go ahead and graph this. Let's do -2 and 1/16. So -2 and 1/16 would be barely above the x-axis. In fact, that's probably a little bit too high. And then 1/4 would be about right here. And then 0, 1, that's going to be about right there. So not very interesting so far. And then we graph 1, 4, so over 1 and up 4, so about right there. So a bit of a bend right here. And then 2, 16, so over 2 and up 16, so we get something that looks like that. Now, if we were to plug in numbers that were a little bit smaller, like -3 or something like that, these numbers are just going to get smaller and smaller and smaller. And if we were to plug in a +3, they would get bigger and bigger and bigger. So here's what's going to happen. We're going to run along right here, very small numbers here, and then it's going to go up like this, going to grow really, really quickly. All right, so that's what that one looks like. Again, we put arrows on the end there. Let's come over and take a look at this one. What's going to happen on this one is we've got 4 to the x, and then we're going to multiply this by 2. We'll plug in the -2, so this is going to be 2 times. This is 4 raised to the -2, so this is 2 times, remember, this was 1/16. So we end up with, if we think of that as a fraction, I'm going to do some cross-canceling here. 2 goes in here once, goes in here 8 times. So this is a 1/8. All right, so we'll graph that one. Then we're going to do 2 times 4 to the -1. Remember, 4 to the -1 is 1/4. Again, we'll do some cross-canceling here, so this is going to be a 1/2. So we get 1/2 here. 2 times 4 to the 0 power. Remember, 4 to the 0 power was 1, so we end up with a 2 here. and then 2 times 4 to the first, that would be 2 times 4, so we end up with an 8. Catch up here. And then 2 times 4 squared, this is going to be 2 times 16, so we end up with 32. So pretty big number there. So let's go ahead and graph this. -2, and then we go up an eighth, so we hardly go above the x-axis at all. -1 and 1/2, so we're going to go -1, and then a half would be around right there. Tough to graph those perfectly. Then 0, 2, probably about like that. Then 1, 8, so over 1 and up 8, around there. And then 2, 32, so over 2 and then up 32. Let's see, this is 20, 25, 30, so probably somewhere about right there. So you can see that this shape is kind of the same. We run along here, and then we start to get really big really quickly. Put some arrows on there. So it says, what similarities and what differences do you notice about the graphs in A and B? Well, something that makes them the same, something that's a similarity, is they do have kind of the same basic shape. They run along here along the x-axis, really small function values, and then they shoot up really quickly. So we're just going to write same basic shape. Same basic shape. Okay, and then a difference would be, if we take a look over here, this is really, really steep. Notice the points are a little bit taller over here, and this grows really, really quickly. We were off the chart over here once we got to 2. So the graph in B is bigger, steeper, taller, however you want to see it. Graph B is steeper, taller than graph A. All right, let's slide down here and let's take a look at this next example. This is 1 star, so it's going to be pretty closely related here. So this says f of x is 1/4 raised to the x, and same instructions there, except for we don't have these scaled yet, so we're going to want to keep that in mind. So it does say scale them both the same. These are somewhat closely related. You can see that we've got some sort of basic exponential here, and then we've got the same type of thing there. So let's see what we get here. When we plug in a -2, this is going to be 1/4 to the -2. Remember, the negative in the exponent means reciprocal, so I'm going to flip this one over. So this is going to be 4 raised to the second power, so that ends up being 16. All right, so there's our first point. We've got 1/4 raised to the -1. Again, the negative part means reciprocal, so let's do the reciprocal of 1/4, which would be 4. So we've got 4 to the first, which is 4. Okay, and then we've got 1/4 to the 0 power, so remember that's going to be 1. Nice to take advantage of that every time. And then we've got 1/4 raised to the first power. That's not going to change it at all because we just have 1/4, just plain old 1/4. Okay, and nothing else to multiply it by. And then we've got 1/4 squared. So remember, the exponent applies to the top and bottom, so this would be 1 squared and 4 squared. So we'd have a 1 here and a 16 here. So this is going to be 1/16. Okay, so -2 and 16, and then 2 and 1/16. So if we scale this the same way they did on the last one, so let's go -5, -4, -3, -2, -1. We've got 0 right here. 1, 2, 3, 4, 5. And then let's go 5, 10, 15, and 20. And then -5, -10, -15, -20. We'll go over here and we'll do the same thing on this one. So we've got 20, 15, 10, 5, -5, -10, -15, and -20. And then -5, -4, -3, -2, -1, 1, 2, 3, 4, 5. So we've got them both scaled the same there. And let's go ahead and graph this one. -2, 16. So that would be back 2 and up 16. -1, 4, so about right there. 0, 1, about right there. 1 and 1/4, so over 1 and up a 4th, so barely above the x-axis. And then again, continuing to get closer and closer and closer to the x-axis here. So we're going to go like this. We're going to hit each one of these points, or at least as close as we can. Going to run along like that right there. So there's the graph for D, and let's go ahead and take a look at E. On this one, we've got the same function right here, but then we add 5. So if we were to plug in a -2, and I'll do this on the first one, this would be 1/4 to the -2 plus 5. Remember, this is going to be 1/4 to the -2 turned out to be 16. So this is going to be 16 plus 5, so that's going to be 21. we had 1/4 to the -1 plus 5. So this turned out to be a 4 plus 5. Okay, so we had the 4 here, and then we're going to add 5. So this is going to be a 9. And then remember, this is going to be 1/4 to the 0 power plus 5. That's 1 plus 5, so that's going to be 6. And then 1/4 to the first power plus 5. That's going to be 5 1/4. And I'm going to go ahead and leave it like this, 5 1/4. We could change that to 21/4. But we'll go ahead and leave it as a mixed number. We don't often do that. And then that makes the next one here. Remember, this is going to be 1/4 to the second plus 5, so that's going to be 1/16 plus 5. So we end up with 5 1/16. Okay, so let's take a look here. -2 and 21, so we're going to be way up here. -1 9, so we'd be about right there. 0 6, about right there. And then 1 5 1/4, so about right there. And then 2 5 1/16, so about right there. Now what's going to happen on this one is if we were to plug in larger and larger numbers, this fraction part that we're adding to 5 gets smaller and smaller and smaller. So this is going to have the same basic shape. It's going to run along here, and then it's just going to get closer and closer and closer to 5, that horizontal line of 5. And it says, what are the similarities and differences you notice about the graphs in A and D? So let's slide up here. Let's take a look at A and D. A and D are these guys right here, okay? So we've got 4 to the x, which makes this shape right here. And then we've got 1/4 to the x, which makes this shape right here. So they have the same basic shape. It's just that one goes up and one goes down. So here's what we're going to say on the similarities and the differences. So I'm going to go ahead and write down that they are the same because they have the same basic shape. Same basic shape. Same basic shape for both of them. And the difference here is that one of them increases. One of them goes up. So this one up here went up from left to right, and this one right here goes down from left to right. Same basic shape, but one goes up and one goes down. So one increases, and the other decreases. Okay, well, the one that increases, remember, that was A, and the one that decreases, that's this one right here. It goes down from left to right, so that one's D. Okay, and then let's take a look at D and E. It asks us to make a comparison between the two of these. So this one right here, it goes down from left to right. It's decreasing like we had before. And then remember, we took those same function values, and all we did is we added 5 to every single one of those. So this has the same shape. The only difference is it's been moved up 5 units. So we kind of slid that upward. So for same, we're going to write this. They're the same in the fact that they really have exactly the same shape. So I'm going to write exactly the same shape. Same exact shape, but they're different, and here's why they're different. They're different because the second one has been moved up 5 units. So graph E has been moved up. And it actually got moved up 5 units. Up 5 units. 5 little tick marks there. Now, I do want to point this out. In each one of these XY tables, every single one of them, the X's were picked for us. The fact that they were picked for us and all we had to do is just plug those in, that is really helpful. The reason that was helpful is these points right here really indicate where that bend happens, where that kind of curves from going down here to kind of flattening out. Or if we're looking at these up here, it's where it goes from being kind of flat right around here to kind of going up like that. So that's a really good thing to keep in mind. We're going to learn how to graph exponentials a whole bunch in the next unit, so kind of keep that in mind. These are really important. Go ahead and do the self-assessment here, and then get started on the assignment.